Welcome back, students. So today we'll find one more question, like we'll see one more question where we have to find G composition F. Okay, so what is the question? They've given us two functions F and G. So F is mapped from set 1 comma 3 comma 4 to 1 comma 2 comma 5, and G is mapped from 1 comma 2 comma 5 to 1 comma 3. So what is the domain of F? This is the domain of F and this is the codomain. Similarly, this is the domain of G and this is the codomain. Okay, and what they have given F. So what kind of function it will be? So they have given it in the form of ordered pair. So F contains the ordered pairs of the form 1 comma 2 3 comma 5 4 comma 1. So now what does this mean? What does this ordered pair mean? That F contains ordered pairs of the form 1 comma 3 or 1 comma 2 3 comma 5 and 4 comma 1 means it is nothing but F of 1 is 2. Okay, ordered pair 1 comma 2 belongs to F means F of 1 is 2. So what is ordered pair 3 comma 5 belongs to F means F of 3 is equal to 5. Okay, so ordered pair 4 comma 1 belongs to F. What does this mean? That means F of 4 is 1. F of 4 is 1. Okay, so whatever the first element in the function represents the elements from the domain. So elements from the domain we represent it as F of, and the second element in the ordered pair represents the answer, the range set. So here F of 1 is 2, F of 3 is 5, F of 4 is 1. Okay, similarly, what about G? G has ordered pairs of the form 1 comma 3, 2 comma 3, 5 comma 1. So what does that mean? G of 1. What is the first element in the first part of the first ordered pair? F G of 1 is equal to 3. Then G of 2 is equal to 3. And then G of 5 is equal to 1. Okay. So now we have these things. Now, can you so they have asked us to find G composition F. We have to find what is G composition F. So why they have given only G composition F? What is the necessity when we have to go for the composition? If we are going for G composition F, the domain of G, correct? The domain of G should be equal to the codomain of F. Only then we can say that G composition F is defined. Okay? How can we say that a composition is defined? If the domain of the first, that is G, is equal to the codomain of F. Whether this is true in this case, what is the domain of G? This is domain. Okay, this is domain, this is codomain. Correct. What is this? This is domain of F and this is codomain of F. Correct. So now, according to the rule, in order so that the composition to be well defined, what does that mean? The domain of G, okay, domain of G should be equal to the codomain of F. Whether those two sets are equal, yes, you can see G has 1 to 5. Similarly, F also has 1 to 5. So, domain of G is equal to codomain of F. Therefore, G composition F is well defined. So, G composition F is again a function. So, from where this function is defined, what might be the domain? The domain is the domain of F. So, that is 1, 3, 4, and codomain is the codomain of G, that is 1, 3. I hope you are clear. How did we write this? In order that the composition to be defined, the domain of G should be equal to the codomain of F. Yes, so the composition is defined. Now we need to check what kind of domain composition function has. So the composition function has the domain of this function. The domain of F is same as the domain of composition G composition F, and the codomain of G is same as the codomain of G composition F. Now what and all we have to find? We have to find what is G composition F of 1, what is G composition F of 3, and then we have to find what is G composition F of 4, because the domain has only 3 elements, 1, 3, 4. So we need to find what is G composition F of 1, what is G composition F of 3, what is G composition F of 4. And whatever we get the answer, make sure that to verify that answers should be in this set. the set which contains 1 and 3. So either your answer should be 1 or your answer should be 3. Okay, so now how to write G composition f of 1? It is G of f of 1, correct? But what is f of 1? We know that f of 1 has a value. What is that? G of, G we are writing as it is. First we have to, here we have to apply that BODMAS rule. What does that say? First always you have to solve the bracket. So inside the bracket it is f of 1. So f of 1 is 2. So now you can solve this. What is G of 2? G of 2 is 3. So G composition f of 1 is 3. Okay, and then next you come up with G composition f of 3. So how you will write this? G of f of 3. That is equal to G of, what is f of 3? What is the answer of f of 3? Just check, what is f of 3? f of 3 is 5. So it is 5. G of 5. But we know what is G of 5. What is G of 5? G of 5 is 1. So G composition f of 3 is 1. Next we have G composition f of 4. So what we have to write? G of f of 4. That is G of, what is f of 4? f of 4 is, what is the value of f of 4? It is 1. So G of 1. But what is G of 1? G of 1 is 3. Okay. So 1 is mapped to 3, 3 is mapped to 1 and 4 is mapped to 3. So what are the elements in the G composition F? 1 is mapped to 3. So 1 comma 3 comma 3 is mapped to 1. So 3 comma 1 comma and 4 is mapped to 3. So 4 comma 3. So this is our G composition F. I hope you are clear how to find, how to recognize the composition, what are its domain and codomain. If you have any doubts, I'll explain it. We'll do further more problems so that it will be clear. And regarding the notes, I'll send it by today or tomorrow, because due to some work I couldn't send you the notes, but by Saturday I'll send you the notes. Thank you.